A transformer consists of two or more coils of wire wrapped around the same magnetic material. If a DC current passes through, then the transformer doesn't do anything, and the coils behave the same way they would if they were replaced with normal wires. But if an AC current passes through, then something very different happens. The current flowing in one coil causes current to also flow in the other coil. The transformer can make the voltage bigger or smaller depending on how many turns are in each coil. The voltage is the energy per charged particle. Suppose we represent the energy as boxes attached to the charged particles. The transformer does not create or destroy these energy boxes, but only moves them from one side of the transformer to the other. This means that the side of the transformer that has the higher voltage must also have a smaller number of charged particles flowing through it each second, so as to keep the total amount of energy boxes constant. The number of charged particles flowing each second is what we refer to as the current. The higher the voltage across a light bulb, the higher the current that flows through it. Suppose we connect a light bulb to an AC voltage source. Now, suppose that in between the AC voltage source and the light bulb, we add a transformer that increases the voltage. Since the light bulb now has a larger voltage across it, a larger current now passes through it. In order to keep the number of energy boxes constant, An even larger current must now pass through the AC voltage source. Now suppose we have two transformers, one which increases the voltage, and then one which decreases the voltage. We now have the same amount of voltage across the light bulb as we had originally, with no transformers present. This means that the current flowing through the light bulb and the current flowing through the AC voltage source is the same as we had originally, with no transformers present. But the current flowing in between the two transformers is much smaller than the current we ever had flowing through the circuit before. This can be desirable if the distance between the AC voltage source and the light bulb is large. This is due to the fact that the wires are not perfect conductors, and they have some resistance. The longer the wires, the higher their resistance. The higher their resistance, the more they cause some of the energy flowing through them to be converted into heat. The energy converted into heat never makes it to the light bulb. We can reduce the amount of energy that is converted into heat in the wires by reducing the amount of current flowing through them. And we can accomplish this by adding the two transformers that we saw earlier. This is the principle by which electric utilities use transformers to deliver electricity to people's homes much more efficiently. Much more information about electricity is available in the other videos on this channel, and information about why transformers work the way they do is available in the video titled Electromagnetism: Maxwell's Laws. Please subscribe for notifications when new videos are ready.